Hello and welcome. The start of this video is going to be building a stand for the Victron Quattro. That might not be interesting to some people. I wanted to include it. It's really just rapid jump cuts, but I wanted to include it in case anybody's trying to do this and isn't familiar with how to do some woodworking. They might find some value into it. That's the core of this channel, is you're a beginner. You need to learn everything, as I did. So if you don't care about the process of building the stand, jump to this timestamp. I'll try to make it linkable. I've never tried doing that before. Welcome to the basement / workshop / floor. I set up the Quattro upstairs, realized it's really quite big for my desk, and I want to build a stand for it. So before we get started, a really quick montage of me building a stand. It's not pretty, it's just functional. The final resting place, whilst it's in the house, is not upstairs. It's going to be downstairs where it's impossible to film, which is itself only temporary until I move on to the boat. But anyways, enough of that. Let's start making some sawdust chips. As with everything else not permanent, the SketchUp for this is really rough and simple. There we go, the camera caught up with the lighting. I know you can't see it, but I've got the first sawdust on my brand new camera. I feel like it's mine now. All right, so I got a little bit more to do, but I'm done with this saw. All I'm gonna do is, in the legs, I'm gonna cut a little bit of a relief so that when the uprights go into it, they actually slot in. Really important again, but it makes me feel better just to know there's some like mechanical lock, considering how heavy that thing is. All right, how's this?
And stones, yeah, they might kill me one day. I'm not ready to die on your doorstep. Being alone, well, that's never easy these days. I'm not ready to quit on you quite yet. I've been climbing some mountains. I've been fighting some lions. I've been looking for you. I've been looking for you. I've been climbing some mountains. I've been fighting some lions. It's so hard accepting the truth that I'm with you for every step of the way through all time. So give me a reason to leave and I'll walk away. As long as you look at me with those eyes, I'll stay. I've been climbing some mountains. I've been fighting some lions. I've been looking for you. I've been looking for you. I've been climbing some mountains. I've been fighting some lions.
That kind of looks like a Quattro gallows.
I've been climbing some mountains. I've been fighting some lions. I've been looking for you. I've been looking for you.
we go. One Victron Quattro stand. Let's crack this thing open. Risk of electrical shock. Do not remove cover. No user serviceable parts inside. Refer servicing to qualified service personnel. So before we even open it up, we're already breaking the rules because I am not qualified. But let's see what we can do. All right, let's see what we have here. Let me see if I can move you in. So on the far right here, we have ACN2, and on the far left, we have ACN1. The manual says that ACN2 is generally shore power, ACN1 is generally your generator. In my case, I don't have a generator, so I'm going to run the shore power, the connection to the house mains, into ACN1. I'll change that later when I actually have a generator and I get on the boat. In the center here, we have our battery positive and battery negative. And over here on the far left, we have AC in 1. As we mentioned, this is where our mains is going to go to for now, until we get a generator. AC out 1, common neutral, and AC out 2, and of course a common ground. The way that the Quattro works is that AC out 1 is protected and boosted. AC out 2 is neither. What does that mean? When you have power coming in either via ACN1 or ACN2, AC out 2 will have power. However, if the current draw on AC out 2 tries to exceed what it's designed to, it just stops working. It just can't produce enough power. It will not use the batteries to boost that. Similarly, if I lose power on both AC inputs, the output 2 shuts down. So they talk about putting non-critical loads on there like an air conditioner or hot water heater, things that would drain the battery really fast, but you're going to live without just fine. AC out 1 is battery protected and it's boosted. What that means is that if both inputs are lost, it immediately starts drawing on the battery to continue to provide output. That's the inverter component of the inverter charger. But it also is able to boost the power. So normally you have a finite amount of current coming into your AC input or inputs. And so long as your load is less than the input power, it uses any access to charge the batteries if necessary. Otherwise, it leaves the batteries alone and you're golden. However, if you turn on enough loads in your boat or RV or whatever that exceeds what the shore power can provide or the generator can provide, it will start drawing out of the batteries to boost the amperage up. So this can provide a maximum of 100 amps out, and it can draw a maximum of 42 amps out of the batteries, giving you a combined maximum capacity of 142 amps output on the AC out 1. This is all in 120 volts, of course. Now, that is predicated on the idea that your AC input, be it shore or generator, can provide 100 amps. If it can't, then it's going to be whatever that limit is, plus whatever the battery can provide. Similarly, if your battery can't provide 42 amps, it's not going to be able to provide it. So don't assume that you're going to just instantly get 142 amps. It'll be the sum of the maximum output of the battery plus the sum of the maximum input of your shore power or generator. Looking along the bottom here at these optional connections, the trickle charge option is not available on the 48 volt model, which I have here. That would be used to charge a starter battery if you had one for a diesel engine or whatever. I'm not sure why it's not on the 48 volt, but that's where it would be if you get a 12 or 24 volt model. So the voltage sense option on the far left, positive on the left, negative on the right, is there to help measure the battery voltage more accurately. Over long runs, the voltage, it's a factor of how much power you're drawing as well, the voltage will drop from the point it leaves the battery until the point where it's connected here. So if that's a concern for you, you can run a voltage sense line directly from here right to the batteries. And that sole job is to measure the voltage, so it's going to be relatively low current, so there'll be less of a voltage drop and it'll be a more accurate reading. So next we have a temperature sense. Most batteries, the way they're charged is dependent on the temperature of the battery. Now in our particular case, I don't think we need this because we have a BMS and a smart shunt and everything contained inside the battery. But if you wanted to use this to allow the Quattro to be smarter about how it charged your battery, you would run the temperature sense positive from here. And this is included with the Quattro, by the way. Run it out, and then the negative is tied to the battery. I'm not sure why it's showing a negative input here, but the manual says to tie the negative to the battery. Initially, I'm not going to be using it either. I've not been able to find in the manual yet, what auxiliary 1 and 2 is. The ground relay and the K1 and K2 are relays that can be programmed to do things like automatically turn on a generator. One thing I read about AC out 2, when there is a power loss and the only power available is from the battery, it'll immediately disconnect AC out 2. When power is restored, AC out 2 will not come back on for 2 minutes. The idea behind that is to allow the generator, assuming it's running on a generator, time to stabilize before it flips that load on. I mention this because I can imagine if I hadn't read that and I reapplied power and I wasn't getting anything out of AC2 for 2 minutes, I probably would give up before 2 minutes had passed thinking something was wrong. So yeah, restore power, give it 2 minutes, then AC out 2 lights back up again. Looking in the top, that is the connection for the remote control. I don't have that, it's an optional thing. Here's a set of dip switches for configuring the operation. We'll go into that later. I don't know how it works yet, I just read it in the manual. So this here is the programmable relay that is used to start a generator automatically on AC failure. Kind of too big. So one of the things right off the bat, I'm not going to be able to turn this on in this video. I had really hoped to get the Victron to the point where I could do that, but one of the things with starting a project is realizing constantly, oh look, I'm missing a part. You get that part? Oh look, I'm missing another part. I'm going to be running 20 amp, 12 gauge Lumex for the AC side, and I don't have any 12 gauge to M6 ring terminals, so I've got them on order. Similarly, the studs for the batteries are M8, which is like 5/16. I don't have any of those either to 4 gauge. So I've got those on order as well. So I'm going to wire up as much of it as I can. That means wiring up I've got a couple of 20 amp AFCIs. I've also got, I've got a spool of, I also got a spool of, 4 gauge Anchor marine wire. This stuff's not cheap. However, it got a lot cheaper when I bought it in bulk, and I will eventually use it for the boat, so I thought I'm just gonna buy once, cry once. It brought the price down to like $140 a foot instead of $340 a foot I was paying, so it was worth it. Anyways, I've got enough black 4 gauge Anchor marine wire, and now with the spool I've got enough red wire to run the battery over to the Victron. So my current goal for today is to get the load side Anderson connector and the boot made with these things, which I had a lot of fun crimping. Get the 20 amp 120 volt wires run to the outlet. I'll fish everything through, and then I'm going to leave it dangling until the other parts come in. All right, let's have some fun. So this length here is the furthest I can imagine wanting to bring this from the Victron. The Victron is right there. I just ran some of the Lumex in through the bottom gland and looped it over, and then just brought it over to where I'm working. Once I cut this, I will cut the second one to length. I'm running two separate 20 amp circuits. The reason I am using 20 amp circuits is because I work in IT, as I've mentioned a few times on the videos, and to simulate an electric motor load that I'll have on the boat, I'm hoping to be able to run a rack of servers. In it are two 20 amp 120 volt UPSs that run our company's product. So my goal is to actually use the battery and the inverter charger to drive that load throughout the day. I didn't bring a knife. Oh, I have a raw razor blade. That'll do. For ABYC standards, which this is very much not, you have to have hooked spade connectors when you run your AC lines into the outlets on a boat. I know that this is not ABYC compliant. I don't care at this stage. So as I understand, you'll see that on all electrical outlets, including this one side has silver posts, one side has brass posts. Brass post is hot, which is the black wire. Silver is neutral, which is the white wire. And the green post at the bottom is ground, which is the bare wire. I'm switching to the flathead because the starhead, I know they have proper names. It was jumping out and I wanted to get a bit more torque down on this. What I'm doing now is just making sure I don't have any shorts. So I've got the positive on the neutral wire. Does not matter which one it is, I'm just looking for shorts. No connection on the hot. No connection to the ground. Ground to hot, nothing. Chassis ground to the wire, I have ground, I have a connection. You want the outer chassis of your switch boxes to be grounded. So I ran the ground wire straight to the outlet, but it's grounded through this post. So that's what I was checking here. Just to make sure the whole box is grounded. One of the things I learned from my electrician, one of the ways to know if somebody who knew what they were doing did the electrical in a house or a boat or whatever, look to see how they put the screws on the faceplate. If they're all in line, then it's not to say it's a good job, but at least they knew enough to make it look like a good job. All right, same deal. Let's be careful. Neutral to hot, nada. Neutral to ground, nada. Hot to ground, nada. Chassis to ground wire. We're good. There we go. As soon as I get the ring terminals in and I can connect it to the Quattro, those are my two 20 amp AC outputs for the Victron Quattro. Okay, let's make the battery cables. Oh, that's hard on the wrist. There we go. You know, when I think about my life, and I think about the things I'm most grateful for, building things, not being afraid of trying to build things, has got to be one of the absolute best gifts you can possibly have. And I am so eternally grateful that my life worked out such that I've never been afraid to try things, because, you know, failure ain't that bad, and success is so bloody sweet. Ah, my necklace is caught. Oh no, I broke my necklace. That makes me sad. Shall we continue? So now I want to rotate these. Actually, let me see if I can get a better picture of this, because I don't know if I showed it well last time. You see the profile of the plug? There's a little lip here. You can hear my fingernail getting caught in it. On the other side, it's rounded. Nothing gets caught on it. If you can see, let's see how the camera shows this. There are metal plates at the bottom of this Anderson connector that are just kind of floating free. The end of that plate grabs on to the end of the aggressive lip. I don't know if it's aggressive lip is the right way to say it, but it's a 90 degree instead of a bulge. So that's what we need to twist the wires so that the bottom edge is going to grab the bottom of the clip. Now, if you also notice the clip, see how there's like a divot on the top and it's flat along the bottom? Inside the actual connector, the boot, I don't know if you can see that or not, but if you can see that, there's a bump along the top and there's no bump along the bottom, it's flush. So that's how we know which way this needs to go in. So the bump right now is along the top here. So that means the bump like that, I want to put it in like this. Positive on the left, blades are facing down. So I want to turn that aggressive edge downwards. So I'm just going to twist it until both of them are downwards. Both of them are roughly the same distance out. And shove them in. Positive on the left, negative on the right. One, two. Now I should be able to pull this back and drive it home. One of the things when I see a lot of these videos, most of the videos are made by guys, which, you know, awesome, bloody awesome, glad the guys are doing this. But they definitely have more strength than we do, and that's okay. We just have to be a little bit more persistent. Is that all the way in? I don't know if there's supposed to be a little... That was my drill. I don't know if there's supposed to be a little lip there visible or if it's supposed to sink all the way back, but I can't get it any further right now. It feels like it's all the way in, so I'm going to call that done. So there we go. We have our load side. Is there anything more I can do at this stage? I don't think so. So, as much as I really wanted to connect this Victron and fire it up tonight, I have all the right parts on order. I don't see a reason to rush it at this point, so I'm going to call the video here. I'm sorry, I like to accomplish at least one proper task per video. I'm the Digital Mermaid. Next time, hopefully we turn on the Victron Quattro. I really wished we could have done it this time. C'est la vie.